Hello! In this video, we are going to prove the following theorem. Suppose G is a group with identity element EG, and H is a subgroup of G with identity element EH. Then EG is equal to EH. In other words, we are proving if G is a group, then all of its subgroups have the same identity element as G. So we don't need to distinguish between the identity element of G and the identity element of any of its subgroups. Now, before we get into proving this theorem, let's first remind ourselves of some things. First of all, what does it mean to say G is a group with identity element EG? Well, it means that G is equipped with a binary operation which satisfies the following. So G is closed under the binary operation, and the associative law holds. The identity element of G tells us for all A in G, A times the identity of G is equal to A, and the identity of G times A is equal to A. And also, every element of G has an inverse. And for now, we are going to denote the inverse of A in G as this. So then, what does it mean for H to be a subgroup of G with identity element EH? Well, that tells us that H is a subset of G, and H is a group under the same operation as G. So H is closed under that operation. The associative law holds, and the identity of H tells us for all A in H, A times EH is equal to A, and EH times A is equal to A. And also, every element of H has an inverse. And for now, we are going to denote the inverse of A in H as this. Now, in proving this theorem, we are also going to be using the cancellation law for groups. That tells us the following. We have, given elements A, B, and C in the group G, if A times C is equal to B times C, then A is equal to B. Okay, so now let's get into proving this theorem. Now, the whole goal is to prove that EG is equal to EH. Now, by definition, by the identity element of a group, since EG is the identity of G, this means that EG is an element of G that satisfies this property. And also, since EH is the identity of H, this tells us that EH is an element of H that satisfies this property. Now, we know that H is a subset of G. So since EH is an element of H, that implies EH is an element of G. Now, EH is an element of G, but remember, this statement works for every element of G. So in particular, it must work for EH. So taking A to be EH, we have that EH times EG is equal to EH, which is equal to EG times EH. And also, since EH is an element of H, and this statement works for every element of H, then in particular it must work for EH. So taking A to be EH, we have that EH times EH is equal to EH. And now we see EG times EH is equal to EH, and EH times EH is equal to EH. So these two guys are both equal to the same thing. So they must be equal to each other. And now we're in a position to apply the cancellation law. So applying the cancellation law, we're going to take A to be EG, B to be EH, and C to be EH. Well, in that case, if this is true, then EG is equal to EH. Well, we know that this is true. That's what we have here. So we can conclude that EG is equal to EH. And that is exactly what we wanted to prove. So this completes the proof. And so yeah, that's pretty much it for this video.